go? Okay. All right, hi everyone. My name is AJ. I'm a data engineer at Chartio. So Chartio is a cloud BI tool. Just by show of hands, who uses a BI tool today? Is this mainly a SQL crowd? I'm guessing everyone's pretty familiar with SQL in the room. Use a BI tool. Anyone else use a BI tool? Whether you can use SQL in it, drag and drop? Okay. So a little bit of background then on what I do at Chartio and some of the problems that I run into. So when Chartio was a smaller company, I was basically like a first sales engineer there. So my goal was to get people to sign up with us, but Chartio doesn't do any data storage or data warehousing ourselves, so the product really relies on how your database is set up and how well optimized it is. But the interesting thing is we got a lot of people that were at smaller companies, 30 to 50 person companies, where they hadn't really settled on a technology yet. They weren't sure if they were going to go with a relational database or something like Mongo or something like Hadoop. And it was really up to us to try and help guide them. So Postgres is my favorite database. Obviously, I wanted to guide them towards Postgres. We used to have a lot of people choosing Mongo for application reasons. But then after a little while, we see more people choosing Mongo or Hadoop or basically anything for analytical purposes as well, even if they weren't planning on building their main application on top of it. So this talk kind of came from that, in that we were getting like 10 to 15% of our leads that were not looking at relational databases, and Chartio is very relational oriented because we strongly believe in it. And so I want to kind of cover why these people were choosing to go the opposite direction and some things that Postgres can offer to bring them back, basically. So we're going to talk about that problem. We're going to talk about one possible solution. That first possible solution is going to tie us into this concept of nearness. And then we're going to talk about what I think is the true solution, which is the Postgres extension system. So there's this prevailing view out there amongst some cohort of users that relational databases are kind of stuck where they were in the 90s, that it's rows and columns, it's schema on write, it has the nice things like ACID, referential integrity, constraints, all that good stuff, but that leads to painful migrations. The non-relational world has documents, it's schema on read, you lose all the nice properties with ACID and relational integrity, but you get nice, not clean, but easy migrations. I'm going to breeze through this. So basically, I broke this out into 8 different dimensions. And it's not important. You could argue some of these either way. It's just basically how I broke it out. So everyone's familiar with SQL, and that being the query language for relational databases. Because it's declarative, it's easy for exploratory analysis, and it's easy to teach to non-technical users. So you can get someone up and running with SQL pretty quickly. The non-relational world, you used to have to do a lot of low-level programming. Maybe if you're using Hadoop, it was something like Java. Now there's more systems on top of it today that are SQL-like. Exploratory analysis, so that's basically your joins, and that's where the relational database excels, less so in the non-relational world. And data science and machine learning. This was the big one that people would come to us. Not even true data scientists. I'm not a data scientist myself. I don't really know that much about the advanced statistical stuff. And I can kind of tell when the person on the other side of the phone doesn't know either. But a lot of people wanted to go with different systems because they were interested in the data science capabilities. And they viewed the non-relational world as being a little stronger. So that was sort of the logical. That's like the query layer. That's what you can do analysis-wise. Then there's the physical layer. This is kind of where I work in the ETL data warehousing space and DevOps kind of. I'll breeze through this. Basically, parallel query processing. People tend to think still that databases are single server and there's no parallelizability on them, whereas they hear MapReduce and they instantly think parallel. Concurrency, relational databases get a stronger reputation on concurrency, basically because people have used them as the backend of their applications forever. Obviously, like Mongo gets that as well, but people get a little concerned when they move to some of these distributed systems about concurrency. High availability and replication, so that's something that relational databases have also done pretty well, same on the other side of the fence. But sharding. Sharding is one thing that Mongo we get killed on people just thinking that Mongo has sharding built in, which it does, and that was very smart of them to do. These are not very analytical focused. Those are kind of more running the back end of an application, so it's not going to be as pertinent to this talk, but it's worth mentioning. So to summarize, there's a decent group of people that would come to us thinking that relational databases have nice properties for producing rich data. So I was just at the Rich Data Summit in San Francisco a few weeks ago, where it's a conference that Nate Silver helped run. It was basically about how if you have rich data that's strongly typed, good constraints, nice referential integrity, you can do some nice statistics on it. And relational databases, that tends to be well known that you can do that. And they're easier for non-technical users, like I said before. But there's this view that they probably don't meet the needs of today's analysts. So the data science, machine learning, the parallel processing, which is largely covered in the Hadoop world. And they definitely don't meet the needs of today's applications. So schema migrations, replication sharding, which is basically what Mongo is going to tell you. My view on it is it doesn't really matter either way, because the practical reality is relational databases still dominate the market, both in revenue, in knowledge. So the top graph there is revenue, the green bar being revenue for relational databases. The bottom left-hand is from dbengines.com, which is basically monitoring all the different mentions online of the different database engines. So you can kind of take that as how much sort of support is out there for you if you need help finding answers to questions. And then the graph on the bottom right is job positions. And each three of these categories, relational databases, still dominate. But we still want some of the advanced functionality. I'm not going to lie, I would agree that there's definitely on the other side of the fence a lot more advanced functionality that people are at least very aware of that they're not as aware of in the relational world. So some of that stuff that we're talking about here, we still want to see if we can get that. So what's one possible solution? So my first instinct was to tell people, well, you're really dealing with basic SQL. The SQL that you're showing me right now is really like SQL 99. Like you're really stuck on the select from, where, group by, order by limit, all that stuff. We're at SQL 2011 now, and there's a whole bunch of features in there that can help you do some of this stuff. So whenever I would see someone writing multiple subqueries that they could optimize away into a CTE, whether for performance reasons or just for making the code a little cleaner, I would make those suggestions. There's a whole bunch of other stuff that I could go down the list on. There's a good post here by Marcus Wienen, I think his name is, about what is in SQL today versus what was in SQL 10, 15 years ago. Unfortunately, people's perception of it hasn't caught up. So if that wasn't enough for them, they wanted a little more customizability, I would recommend procedural languages. So if you wanted to get really, fancy with it, you could go and, write procedures in Python. Or if you wanted to do statistics, you could, use PLR. Some of those are built in, and some of them are maintained by the community, and you may get different quality either way. And that works for some of the use cases. Some people would look at that and say, oh, I didn't know you could do that. I'll give that a shot. Other people would sort of balk at it and say, that's nice, it'll solve some of my problems, but it's not going to solve the larger ones. It looks like more of a building block than an actual solution. So that building block thing kind of interested me. Why were they calling it a building block? What was it missing? And that brings us to this concept of nearness. So does anyone know who Rich Hickey is? He created the Clojure programming language. So he gave a great talk that I really liked. The link is right here, and we'll share these slides so you guys can see all this. I try to put as many links in here as possible so you can use it as a jumping off point. He was giving a talk basically about the trade-off between easy and simple, and how people a lot of times they forego simplicity. They give up simplicity basically to get the convenience, the easiness of certain things. And he was talking about software development. I'm not really talking as much about software development. I'm really talking more about data analysis. So some of those things don't apply. And I'm actually going to use some of these as being good things, as these easy, like the nearness being a good thing. He wasn't saying that the nearness was always a good thing, so he probably wouldn't like my talk too much. But I'm going to reference this as we go. And basically, there's three different types of nearness. There's near at hand, near to our skill set, and near to our capabilities. So near at hand, I basically think of as easily installable. Like how quickly can I get this piece of software, and how quickly can I start using it effectively? Near to our skill set, so do I have to learn a new language to start using this, or am I familiar with the constructs, the abstractions, and how modular and composable it is. And then finally, near to our capabilities. So if I'm trying to do something in the data science landscape, does it even support that? The things that I'm capable of doing in my head, logically, like the things I'm trained for, does the tool support it? So that's where I would kind of see the procedural languages and the more advanced SQL kind of falling apart. I could see where people would have trouble with that, getting things installed, having to use those building blocks to build up the more advanced things that they want to do. They were really starting from sort of square one, and I could see why they would balk at it. It was kind of like telling them that they could program in Python, but they only get the standard library. You don't get any, you don't get any third-party packages. So luckily, Postgres, being my favorite database, had already sort of solved this problem. And they have the Postgres extension system, which is basically exactly what some of these people were looking for. So I'm going to go through the different ways that you can sort of extend Postgres that I know of. I'm sure there's others. And some cool extensions that are out there and that you can use today. And we're going to use those to sort of explore what's available. So the first one we're going to talk about is not even really an extension itself. It's the Postgres extension network. This is one of my favorite things. When I first saw this, it really opened my eyes to the possibility of extensions. So almost every other language that you are going to work with in your day-to-day basis has some sort of package manager. It has some sort of repository or index or network where you can easily search through the different software packages that are available to you and download them and get them installed. So if you're familiar with PyPI or pip in Python, Ruby Gems, CPAN, CRAN, this is a very similar concept. And this is really near at hand. So this is making things easy to get started with. So if we take a look on the left-hand side is how you would do things with PGXN, the extension network. And on the right-hand side is kind of like my rough approximation of how you would do it without that. So PGXN searches the network for software you might be interested in. You could do that on GitHub. How well that would work for Postgres extensions, I'm not sure. Same thing for Google or maybe mailing lists. If you want info, READMEs are okay, but there's a lot of nice tagging and stuff on the extension network that makes getting info a little easier. But really, the workhorse of this is the install, load, unload, and uninstall workflow. It's just way easier. So this makes it simple for people to get up and running. The next thing is UDFs and operators. These things don't always have to be related. The way I group them here are just basically based on the extension that I chose to use an example. The extension that I chose to use as an example, what did it excel at as far as the tools that it used to extend Postgres. So PG similarity, this really just uses user-defined functions and operators. So this is something that I would define as near to our capabilities. So if you're someone who's interested in figuring out how similar two attributes are, right, figuring out the similarity coefficient, a lot of these algorithms, how are you going to build those out of the box with just your basic PL language or something like that? I mean, I'm sure you could using third-party libraries from other languages, but you're really going to have your work cut out for you to get the work done that you need to get done. So you can PGXN install PG similarity. Actually, I'm not sure if that one's up on the network, but you conceivably could do that. And you can have this installed in your database right away, and then it's near to your skill set from there on. So if we take a look at this example, the first example there is just selecting from a table, and it's using different similarity functions for each one. So the first one, it's a little small on my screen here. So the first one's using cosine, then it's Jaro, then it's Euclidean, and you're getting right here the coefficient or the distance. So you're just doing a raw select from the table. So that's just using a regular function. We can see another example of this on the right hand that's actually using operators. So the operators are sitting on top of the functions. They're leveraging the functions. And what you can do is you can set a threshold. So at the very top there, you can see it says set PG similarity dot qgram threshold to 0.7. And then in your select, so again, we're using the functions, in the select clause. But when we get to the where clause, now we're using this operator. And it's tough to see, but it looks like 3 tildes in a row, maybe. So that's a PG similarity operator, and it's going to use that qgram function. And when you use the operator, it's going to adhere to the threshold that you set above. So you can see nothing here is below 0.7. So we're defining how close we want these matches to be. So that's just, that library is super small. It's just user-defined functions, just operators, and it's pretty powerful in what it can do. It's largely written in C, and then obviously the API for it is in SQL, so you don't have to know a lick of C to use this thing. You can see on the left-hand side, all the algorithms are defined in C, but then the actual functions, the API is in SQL. So next we have user-defined aggregates and data types. And postgresql-hll is a great example of this. So this is one of my favorite extensions, mainly because I work largely in the data warehousing space, and count distinct can be, a pain in the butt sometimes. So this makes your life a little bit easier in a couple different ways. So one, it gives you an approximate count distinct, so you don't have to actually do the full count distinct. And it's fixed size, so it doesn't take up too much space. And you can customize the precision. So you can say, I'm willing to have this be 2% off, or I'm willing to have it be 1% off, and there's trade-offs. Obviously, it goes slower if you have a more strict precision, and faster if not. And this one, again, is very near to our skill set. So if we look at this, there's really not much changing in the SQL from what we would do with a regular count distinct. So we've got our fact table here. And then we're going to create an aggregate table over there where we're basically just counting users by day. If we look at the SQL that we use to insert into that table, the only thing that's a little funky, that's a little different than what we would normally see, is all the HLL prefix functions down here. So you can ignore HLL hash. Basically, you just need to hash whatever you're aggregating with HLLs. It's just a property of how it works. But the more important part here is you can use a specific aggregate function to spit out an HLL and store it in that table. And it's going to be an HLL that we can then call another function to get the cardinality of it. So this SQL is not, it's nothing crazy. It looks basically like any other fact table, aggregate table that you would build in a data warehouse. And then when we want to select from it, the SQL is equally as familiar. So if we're just going to get the cardinality from the daily table, we just get a basic function here, HLL cardinality. So that's not even an aggregate function, it's just a regular function. Now we want to say we want to get the count distinct for the month. So we have this table, it's count distinct by day, right? If we're going to do this in regular SQL, this is where things get really powerful. Because now if we want count distinct by month, we can't just sum up those counts by day, because we need distinct. So now we're going to have to go run that query over again on the full month's data and recalculate that whole entire set, that whole entire result set. With the HLL extension, there is a really cool aggregate function called HLL union ag. And basically, you can take a list of HLLs or a set of HLLs and aggregate them and get the count distinct within whatever that precision is across them. So instead of recalculating this whole thing grouping by month, we can go off the aggregate table and we can get the monthly count distinct. And you can get more fancy with it. So you can put in window functions to get rolling counts, so on and so forth. So the benefit there is we don't have to hit the fact table to do our count distincts. We can hit the aggregate tables that we already built. Again, this is something that's implemented in C, but you don't need to know anything about it. And you can go in there, take a look at the SQL, and see everything that's available to you. So foreign data wrappers. So foreign data wrappers are usually one of the first extension types that I bring up to people when they're curious about the extension system, because it tends to just blow their mind. But first, how do you create a foreign data wrapper? The foreign data wrapper API, you have to use C. So this is basically a couple screenshots I took from the documentation. There's a whole bunch of other functions that you can implement. So it's a little difficult to build a foreign data wrapper off the bat. You need to know. You need to be a little bit more of a programmer than, say, me, where I really just know Python. Luckily, someone has already created multicorn, which allows you to create foreign data wrappers in Python. This is an extension. It's on PGXN. You can just, PGXN install and PGXN load this into your database. And you can create foreign data wrappers all in Python. So there's some already, really cool foreign data wrappers that people have created with this. It kind of blows the doors open on who's able to actually create a foreign data wrapper. So I thought that was worth mentioning. I chose a somewhat non-standard foreign data wrapper as an example here, just to kind of like show how creative you can get with this. A lot of the foreign data wrappers are just like, go get me data from Oracle, or go get me data from SQL Server, or some other relational database. There's a Mongo one, there's Redis, so it doesn't have to be just relational. But I really like this one. This is someone kind of thinking outside the box, saying, I want to use Postgres to query my server, and I want to see what's going on my server. I want to introspect into processes on my server, memory, whatever. You could get as crazy as you wanted with this. And if you go take a look at this library and how it's implemented, it's like dead simple how much code it takes to get that up and running. So indexes. I'm going to kind of skip over this one. This one I don't know as much about, but it's really interesting. And this is probably, I'm headed on vacation after this, so like this is probably going to be like half my vacation, just exploring what this thing can do. But basically, you can use Elasticsearch as a backing index for Postgres. And they've got an operator in there that allows you to do some pretty advanced search queries. I don't know as much about how it works on the back end. From what I can gather from just briefly looking at it, it uses the index access method API in Postgres, which I also don't know as much about. But it's really interesting. Like, you create your index, and the only thing that's really different is that you have to use their ZomboDB function in the column that you're indexing. And then instead of specifying like the index type, instead of saying like, like with gin or gist, you specify the URL of your Elasticsearch server. So I'm going to take a look at that. If anyone here knows something about that, I'd love to hear more about it. What's that? Can you use Solar? Again, I'm going to have to like look into it. I just found out about this one maybe a few weeks ago, so I haven't had time to fully dive into it, but it looks really promising. So I added a slide in here about composing extension methods. So a lot of the ones that we've covered here have basically already done this. Some of the coolest extensions don't just use one method, but they use multiple methods combined together to get a more creative result. So we saw that in PGConf with UDFs and operators, although those are kind of tightly related. You can't really have an operator without the UDF. And then we saw that in postgresql-hll. That was tightly integrated. This next library, they're tightly integrated as well to a degree, but they just use everything. So the next library is MADlib, and it uses UDFs, operators, UDAs, data types, all custom, and there's a lot you can do with it. So this is sort of my answer to the person who comes to me in a sales process or a customer and says, I can't do machine learning, I can't do data science in Postgres, we're moving to name exotic database here. These libraries exist, and this one's actually, Pivotal is a sponsor here. This one's sponsored by Pivotal. It started at Berkeley, so it was kind of like a pairing between academia and industry, and they really added a whole bunch of stuff to it. So you've got your supervised learning, unsupervised learning, time series analysis, a whole bunch of stuff that you can use just outside of data science stuff, so just basic statistics and utility functions. And then model evaluation. So once you've built up your model, you can cross-validate it and see how well it actually works. And the really cool thing about this, like all the ones that we talked about before, is that the workflow here, it's just all SQL, and it's very like simple SQL. You don't really have to stretch your brain too hard to figure out how this thing works. So this is an example pulled directly from their docs. So you've got a training table here, so this could be any table in your database. In this case, they've got a table that's an ID, It's second attack, it's treatment and trade anxiety, and basically they're trying to figure out if someone's going to have a second attack or not. So they call the MADlib.logisticregression_train function. So they're going to train their algorithm under the hood on this sample data set here. And what you give it is you give it an input table. So the first argument there is patience, which is this table right here, create table patience. You give it an output table to write to, so there's patience log regression. You give it the dependent variable, so the variable that you want to predict, and then you give it an array of independent variables. So you give it basically your features. If you're going to do feature engineering, the things you feed into it that you want it to predict off of. So once you run that, there's some other things here you can give it, like how many iterations you want it to do and some other stuff, but that's the basics of it. And once you run that, you can see what it spits out. So you can select from that output table that you specified up there. And really all that matters is the coefficient here, but you can see a whole bunch of other data that it will spit out. You can get an idea for how well it was able to do. But the real test comes when you actually use it to predict. So down here, they're running off the same sample table. It's not what you would do in practice, but it's just an example SQL query of how you would use this. So on a new data set, you would select the ID, then you use this log regression predict function. You get the coefficient from this table, so the output of the training function. You pull the coefficient from there, and then you feed it the independent variables from the new data set that you're trying to predict off of. So it's really call one function, give it an input and an output table, call a second function that's joining the output table of that first one to whatever table you're trying to predict off of. It's like a 2 or 3 step process, and the SQL is dead simple. The implementation of this one under the hood is not dead simple. So this is a very complex library. They have a nice graphic up here of how it's sort of all put together. And I kind of went into the source code one day and tried to figure out, because the source code at the moment doesn't directly map to this neat sort of stack here. So I kind of went in and annotated which files or which directories map to each section here. And what's cool about it is they kind of tried to create a sandwich here where the low-level code that interacts with the database is kind of isolated from the middle-level code, which is where all your number crunching is going on. That's where all the machine learning algorithms are crunching away. And those are isolated from the higher layers, which are basically PL Python and PL SQL. So this is an Apache incubator project now. And part of that, I'm sure they're going to be looking to port this to other databases. Right now, it supports Postgres, Greenplum, and then Pivotal Hawk, which is their Hadoop thing, which I think uses the Greenplum optimizer, which makes this all work. I could be wrong on that, but basically, it's modular. It's nice. You could extend this. You could conceive of applying this to another database, another Postgres database. So you could take something like Citus data someday, maybe, if it allows you to create your own aggregates or something like that. You could maybe port this over to that. So it's a really cool library, and it makes extensive use of the extension system. So then the final question I kind of get from people after I've shown them all this is they go, yeah, but is it parallel? Can I parallelize it? And they think they've basically stumped me. And they're like, MapReduce, what's up? Well, yes, it's parallelizable. So like I said, that last library was it's largely supported by Pivotal, and it runs on Greenplum. It comes natively with Greenplum. I think that you have to download an extra thing for it, but basically you can install it into Greenplum. Citus data is another example of a database that gives you parallelizability. I don't think it works with MADlib just yet because there's a lot of funky stuff going on there, but Citus data is really good at working with other extensions that Greenplum can't necessarily work with out of the box. Although I saw on Greenplum's wiki on GitHub something about potentially trying to merge some of the features back from mainline Postgres so that you could maybe get some of those extensions. And then, of course, we've got sequential scan coming out. And then I added columnar foreign data wrapper in there just because that's the next question after parallel. Yeah, but is it columnar? Cool. So the last thing I wanted to add here is composing extensions. So in many of these examples, it's one extension, but it's multiple methods being composed together. What if we could compose multiple extensions together? And we can. So this is an example that I don't think really went anywhere, and it seems like someone was just playing with something on the side, but I really like the idea of it. It was just really creative what he was trying to do here. So basically, he was trying to take MADlib, and he was trying to build a custom background worker that would every so often run a regression against almost every table in the database, anything with like a number in it or like a Boolean in it. And it would create a column. So I don't know if you can see here, it says ID, square feet, zip code, price. And what his background worker is going to do is alter that table and create another column called price _ predicted. So he's using a background worker to every, like, I don't know, 5 minutes, run a regression, populate that _ predicted column, and get a predicted value. And the cool thing about it is you can use it with like nulls. So if you have a bunch of nulls, you can say coalesce the actual value and the predicted value. So you get the predicted value based on all the independent variables. So even if you don't have the dependent variable, maybe it's like late arriving data or something like that, you can get an estimate that's auto-generated for you. You don't even have to run the MADlib functions. And you can get an estimate of what it would have been if it was there. So I thought that was cool. I don't know how usable this thing is, but it was an interesting thought of how to combine different extensions together. I want to give this guy credit too, because this second example is also from him. And it's basically taking two of the extensions that we talked about. So it's taking the first one, the PGSimilarity extension, and it's combining that with MADlib to do what he's calling record linking. So basically, you have two tables. The data in them is related. So one table has a name column, the other table has a name column, but the data is all messy. So it's like this table has like first names and last names, but sometimes they're just first names and sometimes they're initials. The other table has the same exact thing. There's no foreign key between them. So there's no nice, neat way to join these two tables. You just have a bunch of messy data. And what he's doing is he's taking the PGSimilarity library. You can see he's passing that in down here as the independent variables. So he's already created a table that is comparing the names, right, using the PGSimilarity library. So he's trying to say, like, how similar are these names? And then he's passing that into the logistic regression function. So he's using those as independent variables to predict whether or not these are the same people. So it was a good use of two different libraries that are totally separate to get an outcome that you couldn't have gotten otherwise. So you could basically, he was able to kind of join two tables together here that otherwise would have been tough to join. So I'm pretty much focused on the analytical world, but there's a ton of other extensions out there. So just to kind of see how far you can push this, people have created entire web app frameworks that sit directly in Postgres. REST API is kind of along the same thing. Unit testing frameworks, I really like this. This actually helps me a lot in the data engineering world, just kind of checking things as you go. This is a new one that lets you do like build an in-database firewall, and people are releasing more every week. So there's a lot out there, and it's pretty cool to see what people are doing, and it's not just analytics based. So what I want people to get out of this in conclusion, basically, is that with Postgres especially, your relational database, it isn't just rows and columns. It's not just select from where, group by, order by, limit. And it's more than a single machine. So you can get parallelism. And you can do a lot of the stuff that you see people picking some of these other databases for. And you can do it with your investment that you have today in relational databases. Investment both money-wise, resource-wise, whether that's people or whether that's knowledge built up within the company. So you want to make sure that you're getting the most out of your investment. And that's it. Thanks, everyone.